Hello and welcome to our lesson on multiplying and dividing rational expressions. So, rational expressions are fractions of polynomials, specifically x being in the denominator of the fraction, right? Having the polynomial in the bottom of the fraction is going to make a rational expression. We know the bottom of the fraction can't be 0, so we are going to assume along the way here we're not going to be including any values of x that would make the denominator equal 0, and that's something that, again, we will talk about in the future. The good news about rational expressions is that the same rules that apply to just normal fractions apply here. So in the last topic, we talked about just simplifying. And when we were simplifying a rational expression, basically we were reducing. It's the same thing we would do if it was a normal fraction without any polynomials. We reduce by dividing what the numerator and denominator have in common, okay? So the same rules that apply to normal fractions, fractions without polynomials, they apply to fractions with polynomials. So if we're going to multiply and divide today, as long as we know the rules for multiplying and dividing normal fractions, we should be okay here. So what is the rule for multiplying just normal fractions? For example, if I said here to multiply 1/2 times 3/5. Maybe it's been a little while, but when we multiply fractions, we multiply straight across the top and straight across the bottom. So 1 times 3 is 3 for the numerator, 2 times 5 is 10 for the denominator. So we multiply straight across the top and the bottom. Alright, so it's pretty straightforward. Straight across the top, straight across the bottom. The only thing that could make this somewhat complicated is the reducing part, because we have options. So one option for reducing is to reduce each fraction before we multiply. So we are allowed to reduce each fraction before we multiply. For instance, in option 1 here, it says multiply 5/10 and 3/12. So you're probably recognizing that both of those fractions are reducible. So I could reduce the 5 over 10. 5 goes in here once and in here twice. I could reduce the 3 and 12. 3 goes in here once and in here 4 times. And then I could multiply straight across the top. So 1 times 1 would be 1, and 2 times 4 would be 8. So our resulting answer would be 1/8. No, that's one option. One option is to, if you notice there's something that can be reduced up front, then go ahead and reduce it, and then multiply straight across the top, straight across the bottom. We are also allowed to cross-reduce. Okay, we are allowed to cross-reduce because everything from the top ends up together and everything from the bottom ends up together. It doesn't matter if we're in the top of one fraction and the bottom of another, right here, with top here, bottom here. It doesn't matter that those are in different fractions because ultimately they end up together in one. So we're allowed to cross-reduce. So again, if I wanted to cross-reduce here, 3 goes in once and then 3 times. Cross-reduce here, 2 goes in here once and in here twice, and then multiply. Straight across the top would be 1, straight across the bottom would be 6. Then that's perfectly legal. We're allowed to do that. So 1/6 would be our resulting fraction. Now the other option is not to do any reducing. The other option is to go ahead and multiply straight across the top, straight across the bottom, and then if we're left with something that's reducible, reduce. So we're also allowed to reduce after the multiplication. And so like here, I notice I can reduce 6 and 3, but maybe I just don't want to do it, or maybe you didn't notice it. So 6 times 1 on the top would be 6, 7 times 3 on the bottom would be 21, and now we have fractions that are, or a fraction, numerator and denominator, that are both divisible or reducible by 3. So if I divide here by 3, I end up with 2. If I divide the bottom by 3, I end up with 7. So 2/7 would be our resulting answer. Okay? So those same 3 options for reducing, we are allowed to do when we multiply rational expressions, fractions that have polynomials. So I prefer, and it'll be up to you. So look at number 1 in the next part here. Example 1, we have 8x cubed over 5x, and we're trying to multiply by 3 over 4x. You could, if you wanted to, do some cross-reducing. So I notice here we can cross-reduce. I also see here that I could reduce within the one fraction. But for problems like these two, I'd like to take option 3. Now, what do I mean by problems like these two? What I mean is every numerator and denominator is a single term. One term, one term, one term, one term. In these particular types of problems, my preference is to take option 3, which I showed you above, which is let's just multiply it all, make one fraction, and then reduce the one fraction. Because sometimes with these polynomials, if let's say we reduced here, this would become 8x squared, and this would become 5, and then I cross-reduce here, this would become a 2x, and this would become a 1. Like, you just end up with these branches and work that kind of spreads out, and then it might be hard to figure out what's left to multiply. So if you're comfortable with that, you can absolutely take any of the options we've talked about, but I like option 3. When all the numerators and denominators are single terms, then I like to take option 3, which is multiply straight across the top, straight across the bottom to make one fraction, and then I like to reduce the one fraction. So here, multiplying straight across the top, 8x cubed times 3, we'd end up with 24x cubed. Straight across the bottom, 5x times 4x would give me 20x squared, and now I'm going to reduce this one fraction. By what do these two terms have in common? The GCF would be, let's see, 4 goes into both of them, and then an x squared in common. So if we divide both the terms by 4 and x squared, we're going to be left with a 6 and an x on the top, and then just a 5 on the bottom, and that would be our simplified answer. Okay? So, again, you can use whatever option you're going to feel comfortable with, but I like option 3. So if you want to try the next one, give it a shot. If not, let's see, I'm going to multiply straight across the top. So 3x squared y times 4 is going to give me 12x squared y. And then straight across the bottom, so 2xy cubed. And now I'm going to reduce by what these two terms have in common. So both of these have in common a 2, an x, and a y. So when I divide each of those terms by the 2 and the x and the y on the top, 12 divided by 2 will leave me 6, and I'll have an x left. And then on the bottom, the 2's are going to reduce out to 1, the x's go away, one of the y's goes away, so we're going to have a y squared left. So 6x over y squared would be our simplified answer. Okay? Now, sometimes the rational expressions that we're multiplying aren't single terms in our numerators and denominators. For example, with these problems, we have a little bit more going on here. Now, when we have a little more going on, when it's more than one term in any of the fractions, what we want to try to do first is factor. And hopefully that's jumping out at you in these problems. So for example, in the first one, I don't want to multiply like I did in the last two and make an x cubed and a 3x squared and a negative 16x and then this. I don't want to do all that because ultimately I'm going to be left with one fraction that I want to try to factor and reduce. So if there are places where we can factor first, let's do that. All right, if we can factor first, let's do that. So when we have more than one term anywhere, and we have anything that's factorable, we're going to factor completely first. Then we're going to reduce any common factors using options 1 or 2, right? Reduce within fractions if we can, cross-reduce if we can, and after we've gotten rid of as much as we can get rid of, then we will multiply straight across the top, straight across the bottom, whatever we have left. So let's factor and reduce, and then multiply. So we'll be using options 1 and 2 here after we've factored. Okay, so in this first example, top of the first fraction, that x squared minus 16 is a difference of squares. This is really x squared minus 4 squared, right? So the top of that fraction is going to become an x plus 4 and an x minus 4. And then the bottom of that first fraction has a GCF of 4. So if we factor out that GCF of 4, that's going to leave us an x plus 3. Times the second fraction, we can't do anything to factor x plus 3. We can't do anything to factor x minus 4, so we'll just bring those over. But now we can do some reducing. Remember, we could reduce within the fractions if that's possible, or we can cross-reduce. So hopefully you're seeing we could cross-reduce a set of x minus 4's, and we can cross-reduce a set of x plus 3's. And so now what's left over becomes our answer. On the top of the fraction we have an x plus 4, that's it. On the bottom of the fraction we have a 4. So some of you from here might be tempted to reduce, but remember, we've got 1, 2, 3 terms in this fraction. They don't all have a 4, so we cannot reduce anything, okay? Can't reduce that 4. So this is our simplified answer. That rectangle, don't know why. I shouldn't care, but that was horrible. Okay, I guess they're all pretty bad. All right, so there that is. Let's try that again. So Number 3, I can't factor x minus 3. I can't factor x squared, so I'm going to leave that first fraction alone. I also can't factor 8x cubed, but I can factor here factors of 3, so 1 times 3 is 3, that make negative 4 would be negative 3 and negative 1, and dividing by 1 is not going to change those. So 1x minus 1, 1x minus 3, x minus 1, 1x minus 3. Okay, now that it's in factored form, what can we reduce? Well, I can definitely cross-reduce x minus 3, and I can also cross-reduce these two. The x squared and 8x cubed, they have an x squared in common. So if I divide here by x squared, I get 1 left, just a 1. If I divide here by x squared, I'm still going to have an 8 and 1x left. And now I multiply whatever I have left. So on the top, all I have left is that 8x, and on the bottom, all I have left is that x minus 1. And that would be it. Those 3 remaining terms have nothing in common, so that is our simplified answer. Okay? Feeling good about this? Give it a try. Like, pause the video and see if you can figure out what's going on in this last one. Otherwise, let's see. X plus 5, not factorable. I'm going to bring that over. 3x minus 6 has a GCF of 3, so I'm going to factor that out. So that coming out is going to leave me an x minus 2 times second fraction. Can't factor x minus 2, but I can factor here. 1 times negative 20 is negative 20. Factors that make positive 1 would be 5 and negative 4, and dividing by 1 is not going to change those. So 1x plus 5 followed by 1x minus 4. Alright, now that we're in factored form, let's see what we can reduce. Definitely a set of x minus 2's, also a set of x plus 5's, and that would be that. Okay, what's left over in the top? When it looks like nothing, remember technically I could say there's a 1 here. So technically on the top we're going to say 1 is left over. And then on the bottom we have a 3 and we have an x minus 4 that need to be multiplied. So we have the option of leaving it in this form. If you also wanted to distribute and say this was 1 over 3x minus 12, you absolutely could. Both are equivalent. I tend to not distribute, just one less spot to make a mistake, but either one is totally acceptable. Okay? So that's multiplying in a nutshell. Factor if it's factorable, and then do some reducing. And then it's multiplying straight across the top and the bottom, unless you have single terms, which you could still use the same options, but I like to multiply, make one fraction, and then reduce. Alright? So if we can multiply, we can divide. And I say this because we don't actually divide normal fractions. So if I said to take 1/2 and divide it by 3/5, do you remember the rule for dividing normal fractions? Well, we don't divide normal fractions, we multiply by the reciprocal. So we keep the first fraction the same, we keep this the same, we change the division here to multiplication, and then we flip the second fraction and make it 5/3. So what we really have is a multiplication problem. So multiplying straight across the top and straight across the bottom would make 5/6 the answer to that problem. So how do we divide normal fractions? We don't. We don't divide normal fractions. We multiply by the reciprocal. Multiply by the reciprocal. I like to remember keep, change, flip, if that helps you or if that sounds familiar. We keep the first fraction the same, change the division to multiplication, flip the second fraction. If that's a little primitive for you, you don't have to think of it that way, but that's what helps me. Okay, so keep, change, flip, multiply by the reciprocal. So what we are going to do is the same thing we did on the front. We just need to rewrite our division problem as a multiplication problem. Rewrite our division as multiplication. Just make sure that we write smaller to fit that in the blank. No, multiplication. What we need to make sure of is that we flip that second fraction, okay? And then we follow the same steps that we talked about on the front. So again, this we're going to keep, this we're going to change, this we're going to flip. So this is going to become 4x cubed over 3y multiplied by the reciprocal of that second fraction, so 9y squared over 2x. And now it's what we did on the front. So these fractions, all numerators, denominators, single terms, this is where I would take option 3. So I'm going to multiply straight across the top to make this 36 x cubed y squared. Multiply on the bottom to make a 6xy. And now I can reduce. I can actually divide on this one, but what do these two terms that are remaining have in common? Well, they're both divisible by a 6 and an x and a y. And so we're going to end up with, let's see, 6x squared y on the top, and then just a 1 on the bottom, which doesn't have to be there. So we can just make this a 6x squared y for our answer. Okay? Not so bad. So same thing. Take our division, make it multiplication. So we're going to keep this, change this, and flip this. Now, if you're okay with multitasking, I notice in this one we also have some places to factor. So I'm going to do two things at once. I'm going to rewrite it as a multiplication problem, and I'm going to factor if I can factor. So I know I'm going to be keeping this fraction as is, but 5x minus 10 is factorable. So I'm going to take out my GCF of 5 here. So if that 5 comes out, I'm going to be left with an x minus 2. So it's still on the top of the fraction, but I factored at the same time. Okay, the 3x is still going to be on the bottom. Now I'm going to change the division to multiplication, and then I'm going to flip the second fraction. So 9x squared is going to go to the top, and the 4x minus 8 is going to go to the bottom, but again, it's got a GCF of 4, so I'm going to take that out. So 4 coming out is going to leave me x minus 2. So I rewrote it, and I factored at the same time. Hopefully we're okay with that. Now what can we reduce? Well, let's see, we've got an x minus 2 in common. And then we can also cross-reduce here and here. They have a 3x in common. So if I divide 3x by 3x, I get 1. If I divide 9x squared by 3x, I'll have a 3x left over. So now what's remaining? On the top, a 5 times a 3x is going to give me a 15x. And then on the bottom, it's just 1 times 4, so 4. The answer is going to be 15x over 4. All right? Feel free to try out the next one. Pause the video if you think you can handle it. Let's see. We're going to keep this fraction the same, but again, I'm going to take out my GCF at the same time, GCF of 3 on this one. So 3 times x minus 1, and then 16 stays in the bottom. We're going to change this division to multiplication, and then we're going to flip the second fraction, and there's nothing to factor on that one, so I just need to flip it. Alright, so now, what can we reduce? Well, let's see, x minus 1 in common, and then we can also cross-reduce. 4x and 16 have a 4 in common, so if I divide here by 4, I'll still have an x. If I divide here by 4, I get 4 left. So what do we have left in our numerator? The 3 times the x, which is 3x, and then in the denominator, the 4. So 3x over 4 is going to be our answer. Okay? So we've got a couple more examples, really doing the same thing, just so we can get some more practice in. So we're going to rewrite this. We're going to keep this fraction the same, but again, we can take out our GCF of 4 here. So this becomes 4 times x minus 3 over, can't do anything with x plus 2. We're going to change this to multiplication, and then we're going to flip this fraction. So x minus 2 goes to the bottom, and the x squared minus 4 is going to be moving to the top, but it is a difference of squares. So these are squares here. That looks like f squares. That's no good. So these are, we're going to flip this, but these are squares. So this becomes x plus 2 and x minus 2. So now we can cross-reduce an x plus 2. And within this fraction, remember that's a legal move, we can reduce the x minus 2. So what do we have remaining? Well, on the top we have the 4 and the x minus 3, and on the bottom we just have a 1, which we don't have to keep. So we can just say 4 times x minus 3 is our answer, or if you wanted to distribute and say 4x minus 12, either one of those would be acceptable. I'm just going to go ahead and box in the 1. And then we're good. Okay? Now that's a little squished, so let me do this again. Just put this up here. Hopefully we're okay with not needing the 1 there. So or 4x minus 12. Either one of these, totally fine. Alright, last one. Again, if you're feeling good, give it a try, pause the video. Otherwise, let's knock this out here. So this is not a fraction technically, but if we put the 1 under it, we can see that it is. So we're going to be keeping this fraction, changing the division or multiplication, flipping the second fraction, but factoring at the same time, so we don't have to do 10 steps. So the first one here, all coefficients of 1, by the way, when we use bottoms up, so we don't need to worry about multiplying and dividing. It's just, what are the factors here of 21 that make 10? Well, that's going to be 7 and 3. So we're going to keep this first fraction the same. That's going to stay on the top. So x plus 7, x plus 3. And then on the bottom, we need factors of negative 15 that make negative 2. So we can use negative 5 and 3. So x minus 5 and x plus 3. Alright, now we can change the division to multiplication. And then we're going to flip this second fraction. So now the 1 goes to the top, and on the bottom, what are the factors of 14 that make 9? 7 and 2. So x plus 7 and x plus 2. So now what can we reduce? Let's see, within this fraction, we've got some x plus 3's in common. And we can also cross-reduce a set of, gray. I wanted green. X plus 7, those can go. And that would be it. So what's left over becomes our answer. So final answer is going to be the 1 left on the top, and the x minus 5 and x plus 2 that is left on the bottom. And again, if you wanted to multiply that out and make your answer 1 over x squared minus 3x minus 10, that would be totally fine, but it's just unnecessary. It's like one more spot where you can make a mistake, so totally okay to leave that unmultiplied. Okay? Well, there it is. Hopefully we're feeling all right with that. Give the practice a shot, and if you need some extra help, just reach out. I'm here for you. All right, guys, take care.